In this video we're going to write code to search for a value in a binary tree, and we're once again going to use recursion, and we're going to use iteration. So these are the two techniques that we're going to use. When we use a while loop or some other loop, that's called iteration, and the other technique to search is using recursion, right? And we obviously all understand what recursion is. So let's say we were looking for a value we were looking for Paris, right? If that was the value that we were searching for in a binary tree, we're going to start here, and let's say our TNP is going to be here, right? And this is going to be the current node, so we'll check if Paris equals Dublin. It is not. If it is not, then we need to decide whether we have to go right or we have to go left, right? Since Paris is larger than Dublin, that's why we're going to go right. When we go right, that means we've updated our TNP. By going right, we mean we've updated our TNP, our temporary pointer, to point to this node, right? So TNP has moved here, right? And now this becomes our current node. And now once again we compare Paris with London, and we see that Paris is greater than London, and these two values don't match, and Paris is greater than London, so we once again go right. So when we go right, that means we've updated our TNP, and TNP now points towards this node, right? And we're looking for Paris, and when we examine this current node, we'll see that the data value in the current node is also Paris. So we found the value that we were looking for. This is where we stop our search, right? This is where we don't need to update TNP anymore. Okay, so that's one way we are going to stop our search. The other way of stopping a search is, for example, if we were looking for a city like Lahore, for example, we start here. This is where TNP is. This is our current node. We compare Lahore. We compare Lahore with Dublin, and we see that they don't match, right? So Lahore is greater than Dublin, therefore we go right. By going right, we mean we've updated our TNP, right, using the right pointer of this node, right? So we've updated TNP, and TNP now points here, and now this has become our current node, and we compare London with Lahore, right? And we see that these two don't match, and we also see that Lahore is less than London, right? Therefore we have to go left, because Lahore is less than London, so we're going to use the left pointer to move TNP. And so we update TNP using the left pointer, but you can see that the value of the left pointer was null, and in this case TNP becomes equals to null. In this case TNP becomes equals to null, and this is where we have to stop our search. So these are the two cases, one where we find our value, and as soon as we find our value we have to stop our search, and the other case is where we can't find our value and we go through our nodes until finally TNP becomes null, and that's where we have to stop. Okay, so we're going to start writing code for this. I'm going to write a procedure, and we'll obviously have to declare a temporary variable called TNP and start moving through the different nodes in our binary tree. Okay, so we've declared a procedure. We have called it search binary tree. That's the name of our procedure, and we're passing it one parameter, data item. This is the value that we're going to be searching for. And just note that we are basically going to be writing an iterative procedure, meaning we're going to use a loop in our code to find the value, right? Now that we've declared our procedure, one of the first things that we need to do is to declare the temporary pointer that we are going to be using to move from node to node. And remember, we've decided that the name of the temporary pointer is going to be TNP. So we've declared our temporary pointer TNP, and now we want to set its position to the first node of our binary tree. Remember, the first node of our binary tree is this node, right? And this is where root pointer is also pointing. See, so we want to set TNP to point to the same node that root pointer is pointing at. Therefore in our code, what we've done is we've set TNP equals root pointer. So now our TNP, which is our temporary pointer, is positioned at the start of the binary tree, and we are now ready to move the temporary pointer through different nodes by using the temporary pointer TNP. So we're ready to travel down our binary tree now. So now we are going to write a loop to move our temporary pointer, to update our temporary pointer, and each time within the loop we are also going to check if we found the value or not, right? We're going to write the code for our loop now. Okay, so we've written our loop, and you can see that this loop will run as long as the value of TNP is not equal to null. So that's one of the cases, right? Remember, this loop should stop when the value of TNP becomes equals to null. But remember, whenever we write our loops, we always write them for the running condition. So this loop will always run as long as TNP does not become equal to null, and this loop will also run if the value of found is false, meaning it should stop if the value of found is true, but if the value of found is false, this loop will keep running. Okay, so what we've done here is we've used a boolean variable to stop our loop, right, in case the value of found becomes true. So once again, this condition is, the condition here is telling us when the loop should run. So the loop should run as long as TNP is not equal to null, and the loop should also run if found equals false, right? Meaning, you know, we've not found the value that we were looking for. So as long as we have not found the value we are looking for, we are going to keep running, and at the same time, you know, we should also make sure that the value of TNP has not become null. So if the value of TNP has not become null, we are going to keep running our loop, we are going to keep moving from nodes to nodes, and, you know, look for the value that we are searching for. Okay, so what I've quickly done here is I've declared my boolean variable found, and I have set its initial value to false right before the loop starts. Now inside of this loop, the first thing that I need to do is I need to check if the current node, that is the node towards which TNP is pointing at right now, does it have the value that I am searching for. So I'm going to check the current node, I'm going to check the data value of the current node, and see if that is the value that I am searching for. And as you can see here in my code, what am I doing? I am actually going to my array called tree. Remember, all our nodes are lying in an array, and because we're working with a binary tree, it makes sense to name our array as tree, right? So I've used tree as the name of my array in which all the nodes are lying, right? So in my array tree, the node that TNP is pointing at, so this becomes our current node, right? This gives me my current node. The data value of my current node, is that equal to data item? Is that equal to the value that I'm searching for? If that's the case, set the value of found equals to true. But if that is not the case, if we've not found our value, then that means we are going to come to the else part, right? And this is the part where we need to write code to move our TNP, our pointer, and we want to move it to the next code. So we want to, and this is the part where we want to update our TNP and move it to the next node. But one thing which is very important and that you should remember is that in case of a binary tree, we always have two options, right? We always have two options, and let me just take you back up to the binary tree. We have two options: either we can go right or we can go left. It all depends on the data values that we are comparing. So for example, if we are comparing Lahore, if we are searching for Lahore, then Lahore is greater than Dublin, so we'll have to update our TNP using the right pointer. But if we were looking for a city that was starting with, for example, A, if we were looking for Athens, right, for example, and then we would have compared Athens with Dublin, and Athens was less than Dublin, so we would have had to go left, right? So in case of a binary tree, when we are talking about updating our TNP, this temp pointer, then we should, you know, make sure, then we have to take a decision whether we have to go right or we have to go left. So this decision needs to be included in our code when we have to update the TNP. And as you can see in our code, we are doing comparisons, right? We are comparing the value that we are searching, right, data item, this is the value that we are looking for. If this value is greater than the value lying in our current node, right, in our array tree, the node that TNP is pointing at is our current node. So we are comparing this search value with our current node, and we are comparing it with the data value of our current node, right. So we are comparing the search value with the data value of our current node, and if the searched value is greater than the data value of our current node, then we have to go right. And you can see here that TNP is being updated with the help of the current node, right. This is our current node, and we are using the right pointer of our current node and assigning its value to TNP. Okay, so that's the case when the data item that we are searching for has a value larger than the value lying in our current node. But if that's not the case, and if the value that we are searching for is less than the value of our current node, in that case we have to use the left pointer. And you can see here that in this case we are updating the value of TNP using the current node, right. This is our current node, and we are using the left pointer of our current node, and we are assigning its value to TNP. So this way, we are going to update our TNP, our temporary pointer, to move to the next node. Okay, let's just take a look at the loop once again. Okay, once we come inside the loop, the first thing we do is we check if we found the value. If we found the value, we set the value of found equals true. Once the value of found becomes equals to true, this loop will not run again, because this loop will only run as long as found is equal to false. But as soon as we found the value and found becomes equals to true, this loop is going to stop. However, if we've not found the value, then we come to this else part, right. If we compare this and the two values don't match, right, then we come to the else part, right. And in the else part, what are we doing? We are trying to update our temporary pointer TNP, right, and we've updated it towards using the right pointer if the value we are searching for is greater than the value lying in the current node, or in the other case, we have updated the temporary pointer using the left pointer of our current node. So once this loop stops, and if for example, there are two ways this loop can stop, right. If we find the value, this loop stops, found becomes equals to true, or eventually TNP is going to become null. When TNP becomes null, this loop stops, right. Once this loop stops, we can now output our message based on the value of found, right. If found equals true, our search has been successful, and if found equals false, our search has failed. So finally we've added that code to our procedure, and if found equals true, we're going to output search has been successful, else we're going to output that search has failed. That completes our iterative solution for searching a value in a binary tree. Okay, so now I'm going to write a procedure to search recursively, search a binary tree recursively, right. And I've named this procedure as search binary tree recursively, and I'm passing two parameters. One of them is the pointer, this will give me my current node, and the other parameter that I'm passing is the data value that I'm searching for. So I need both of these, right, because each time a recursive call is placed, I need to know which node do I want to check for the data value that I'm searching for, right. So both of these values are important, that's why I'm passing both of these. Okay, before we write our code, we quickly need to take a look at the binary tree and understand our possible scenarios. One of the scenarios, for example, is that we're looking for a value that is already there in the binary tree. For example, we were looking for Paris, right. And remember, this is the point where we want to start, right. So TNP must initially be positioned to the first node, the root node of our binary tree, and this is our current node. So we first examine our current node, and we see that Dublin and Paris, they are not the same. That means we need to search further, we need to move TNP further. So we first update TNP. Because Paris is greater than Dublin, Therefore we are going to update TNP using the right pointer. Okay, so now the TNP, so we update TNP and then we place a recursive call. So now that we are placing a recursive call, we are using the updated value of TNP, right? And this becomes our current node, right? And we examine this current node and we see that London and Paris don't match, which means we have to move TNP once again. Because Paris is greater than London, we are once again going to use the left pointer. Sorry, this is the right pointer, not the left pointer. We are going to use the right pointer to update TNP, right? So so we update TNP first and then we place a recursive call, and in that recursive call we pass the updated TNP as a parameter, right? So now the recursive call has been placed using the updated value of TNP, and this becomes our current node, and we can see that we found Paris, and this is where our search is going to stop. So this is one of the ways that the recursive this is one of the ways that our search is going to stop. And but when we say our search is going to stop, that means we do not need to place a recursive call anymore. And we don't need to place a recursive call because we found our value. Now let's consider the second scenario. We are searching for a value that is not there in our binary tree. For example, we are searching for Athens, right? This time we are looking for a value that is not there in our binary tree. Obviously we start our search here. This is where TNP is. This becomes our current node. When we compare the two values, they don't match, which means we need to move TNP further, right? Because Athens is less than Dublin, this time we are going to use the left pointer of our current node to update TNP, right? Once we've updated TNP, we are going to place a recursive call using the new value of TNP, using the updated value of TNP, and we place the recursive call. So this becomes our current node, and in our current node we compare Athens with Berlin, and these two don't match. But because Athens is less than Berlin, therefore we once again are going to use the left pointer of our current node to update TNP. So we update TNP using the left pointer of our current node and then place the recursive call. And this time when we place the recursive call, we can see that the value of TNP is going to become equal to null. So once the value of TNP becomes equals to null, that means we don't have any more nodes to explore. That means our search should stop at this point. Once the value of TNP becomes equals to null, right, we don't need to place any more recursive calls. We want to stop our recursive calls. We want to stop our search. Okay, so now we are ready to start writing our code. Okay, one of the first things that we can do is we know the condition for when our search has failed, right? So let me just write code for that. If TNP becomes equals to null, that means our search has failed, right? And that is exactly what we are showing here. See, this part of the code where TNP is not equal to null, we are going to write later on. But if TNP is equal to null, that means we come to this else clause, right? And we are going to output this message, right? Search failed. This is what happens when TNP is equal to null. But if TNP is not equal to null, then this is the part where we are going to write our code. So if TNP is not equal to null, what we're going to do is we're going to check the current node and see if we found the value that we are looking for. And this is how we're doing it in the code. We are taking a look, we're going to our array list and to the node that TNP is pointing at. So we're going to our array called tree, sorry, not list, array called tree. And in our array called tree, we're going to the pointer that TNP is pointing to. So this gives us our current node, and the data value of our current node, we compare it with the value that we are searching for. And if both of these match, we are going to output that the search has been successful. Now in this case, we do not need to make a recursive call, because our search has already been successful, so we don't need to look for any further nodes, and we need to stop placing our recursive calls, right? However, if we've not found the value in the current node, then we need to place a recursive call. And remember, now that we want to place a recursive call, we must first update TNP, right? We must first update TNP and then place the recursive call. So let's write code for updating TNP. And this is exactly what we are doing here. See, there are two ways that we can update our the value of TNP. If the value that we are searching for, if data item is greater than the data value lying in our current node, then we have to update TNP using the right pointer of our current node, which is exactly what we are doing here. And after we've updated TNP, we are now placing a recursive call, right? We are now placing a recursive call. Remember, this is the name of our procedure, right? So we're calling this procedure search binary tree recursively, and we are passing two parameters here: the updated value of our temporary pointer TNP and the data value that we are searching for. So next time this procedure is called, the new value of TNP will tell us the current node, and the data item will tell us the value that we are looking for. So one of the ways to update our data is using the right pointer. Obviously, we have to first compare these two values to determine whether we are going to use the right pointer, or if that's not the case, then we'll have to use the left pointer, right? When the value that we are searching for is less than the value lying in our current node. So when the data item value is less than the value of our current node, then we are going to use the left pointer of our current node to update TNP. And once we've updated TNP, we are going to place a recursive call to the same procedure itself, giving it the new TNP, which will obviously be now the new current node, right? And the data item that we are searching for. So broadly speaking, what's happening in this code? Let's take a look at this code and try and understand what's happening here. So what is happening is that first, if the value of TNP equals null, we output this message that the search has failed, right? However, if the value of TNP is not equal to null, then this is the part of the code that gets executed. Now we should understand that if the value of TNP is not equal to null, that means we need to examine the current node and see if we found the value, and that is what we are doing here. We check the current node and we see if we found the value, if this data value is equal to the value that we are searching. In that case, we output a message that the search has been successful. However, if the two items don't match, right, if we've not found the data value in the current node, then we need to update TNP, right, and place a recursive call. And in case of a binary tree, we either use the right pointer to update TNP, or we use the left pointer to update TNP, right? But in either case, once we've updated TNP, we've placed a recursive call with the updated value of TNP. And in this case also, we've placed a recursive call using the updated value of TNP. I hope you've understood how to recursively search for a value in a binary tree.